Hi, the topic for our group is manufacturing bicycles, and my name is Jiaqin Zhang.
My name is Jay Gao.
My name is Yifan Dai.
Okay, so it's very clear that our objective is to manufacture a bicycle, and why do we choose? Doesn't work. Okay. Why do we choose this topic? Because we have based on some facts, which is bicycle has been invented more than a century ago, which means it has a very long history, and this leads to that people don't use the latest technology results to this area. For example, axiomatic design principles. So that's what we did in this project. And also there are many bicycles available in today's world, which means if we can improve or we can make some small change to this area, it will have a big impact to this world, to our human. And also it is driven by human power. Nowadays we all pay more and more attention to the environment, so this means that bicycle is a cheaper and a cleaner option for us to choose. So this is our to manufacture bicycle, we prefer to separate the different parts of a bicycle and manufacture them separately. So this can save us time, and it can also avoid the coupling in the DPs and FRs. So we separate them into the handlebar, frame, and the drivetrain to make sure we comply with the CME principle. So we add other parts. So at last finish this part, we also have FR is assemble different parts to make sure we have the whole process. Also, this one is our first level decomposition. Okay, so the FI0 is manufacture bicycles. The corresponding DP is a process to manufacture bicycles. And we, as I mentioned before, we decompose it into several parts, which is manufacture the different parts of the bicycle simultaneously. And after that, we have a special FR, which is the last one, FI5, to assemble different parts. And we have some, actually we worked on every FR to the third level, but we found out we don't have much time for the whole process, so we focus on the drivetrain, and we'll talk about it in the following slides.
Yeah, and then focus on the drivetrain, and from the picture show that clearly that there are 6 parts of the drivetrain, and there's a chain, our crank seat, the chainring, and the coke, and the BB, and the wheels. And Yifan will continue to say something more about the drivetrain. So let's first to focus on the first part about the chain. When we manufacturing the chain, so first we need to know the part of the chain that is just as the picture you see that there are 5 parts about the chain, about the outer plane, the inner plane, the pin, the roller, and the bushing. So we need to manufacture each part of the chain and then to put them together into a whole part. So the FR here for first is that to FR the first 1, 2, 3, 4 are all about the different parts of the chain, and the 5th part is to assemble them together. And so let's to talk about first the inner or outer plant. The outer and the inner plant are always the same, so we put them together to talking about them. And the plant, to manufacturing a plant, so first we need to cut the shape and then to provide a surface treatment and to provide the lubricating and in order to make them better to put together with other parts of the chain. And so our effort here is first is to cut the shape of the plant, and so DP is to process to stem the moldering. And when we stem the moldering first, we need to cut the basic shape of the plant and then to form the holes of each plant. You see from the first picture here that there are two holes of each plant. So first to make a basic shape, and then to make the holes, and third to check if the holes is directly for the location, the right location or the right size. So see from the FR here is the first to cut the basic shape, second to form the holes, the third is to provide inspection, and the DP here is to alter shape using the pushing to make the shape, and to make the holes, and to using using the motor to checking if the holes location is right or the her size is right. And after we cut the shape of the plant, the second pass is for surface treatment. The surface treatment combines three parts here. In fact, is two parts is also okay. First is the heat treatment, and the second one is the pollution. And the pollution here we make them in two mechanical pollution and chemistry pollution, two parts. And first for the heat treatment, and as we choose the materials of the plant, we always choose steels for the plant. So we need to using concision process to make the heat treatment. Well, when we make this process, we need first to provide a high temperature environment, then to make the plant in the high temperature permit for a while, usually for about half an hour, and then to put them in a low temperature environment to finish the heat treatment part. So that we need from the DP here is Francis, and the part 2 is the cold water. Sometimes even we use cold water or cold oils to make a lower temperature environment here. And after that, after the heat treatment, we need to make a mechanical precision here, and we choose silicone foam and with water to mixture with the plant here to make a mechanical precision. We put them together into a machine to make the process. And after mechanical precision, we make a chemical precision, and usually we choose the act picking here. And after act picking, we usually make the plant into a water to mix act out. And after all the process of the manufacturing, we provide the lubricating here, and to make them better to meet with other parts. And here is the matrix of the part of the chain here.
Here's my part, the drive train. The drive train have 5 parts: the train set, the train ring, and the train, the cog, and the bottom bracket. Here's the picture. And my main part is the crack set. Here's a picture of a crack set. One is a left crack set, and one is a right crack set. See, they are different. And in fact, for this crack set, they can separate into 2 parts. This is a crack arm, and this is called spider. And the outside is the chain. This is a chain, and this is the spider. In some older models, they are separate. The crack arm and the spider are separate, not together. But now more and more crack set put these 2 parts together using welding up them together. I searched the question why they put together. They're saying that because in old days, this crack arm are sometimes may broken. So it's easy to change it. So they made two parts. But now with a better technical, they are lifelong time parts. Do not need to change. So put they together means save some steps such as pin link or other things. And for the crack set, there's four index: the stiffness, the length, the interface, and the void circle, the diameter. For stiffness, I searched for some ways, and usually they use the way to. It's called multiple fogging. Multiple fogging can make the stiff material with high hardness and high durable. For crack set, usually use 3 times multiple fogging, but for some great quantity crack set, they can have as more as 26 times multiple fogging. And also why I choose the material aluminum alloy, because everyone knows it's light, and also it can be used for many ways, such as cast or hot forging or cold forging. And it can be very light with great hardness. So I choose this material. And when shipping the crack set, I choose the cold forging with model, because the cold forging. What means cold forging? It means the billet from which the crack is to be made is heated to a specified temperature well below the melting point, not means room temperature. The cold forging not only gives the melter additional strength, but also have good service quality and high precision in sharpening. So it can replace some steps as milling, rolling work, and also it can use less materials, save a lot. So it's a better way. And for then is lens, because the shape of the crack set are quite classical. There's not too much change in the shape, but the lengths are different. As usually the longer the length is, the better, the easier one can ride the bicycle. But too long may touch the floor or touch the wheel. So it's not too long. And for interface, we use CNC machine to do the interface work. First step is the fixture. Fix, and because the structure of this crack set may be not so traditional, so we may need a special fixture. And then they have 2 holes on the crack arm. See, 1 hole, 2 hole. This one is connected to the panel. So it also needs the screw thread on it. And for the other end, this is the hole with the bottom bracket, and also with the spider. So this hole have many different shapes, maybe square, maybe round, and that's all.
Okay, you've already used up your 15 minutes. I see you still have 4 or 5 slides.
Just finish up 1 minute. Sorry for about we didn't plan very efficiently. So just about this one. This is a picture of our decomposition. So our intention is not to change the design of the bicycles, but we want to analyze the process of manufacturing bicycles and to build a foundation for any further improvement possible. And we are kind of excited about our progress because we think this bicycle has been invented for more than a century, but we still find many places we can do improvement, many couples in the FRs and DPs. So the people just do the same as the old generation, but they didn't pay more attention to that. So we have, this is a look of our whole work actually, because it's too long, so I put it in 2 columns. And we have a lovely diagram actually. Okay, thank you for your attention. Questions?
Okay, good. Thank you. That was very nice, and I'm sorry to have to cut you off, but we need to try to keep a little bit on schedule because there's some other people. I just want to make a couple of comments on this. Are there any burning questions? Go ahead.
The problem is that the question is that she suggests us to replace the inspect by control, right? And our answer is that we have already controlled that part, but to manufacture the bicycle, we need some inspect process to make sure the quality. So after we have make this whole product, we want to make sure everything is fine, everything is inside the tolerance. So we have that. So, yeah. Yes.
Okay, good. All right, so in the interest of staying on time, thank you very much. Good job.